Hello, smart mathematicians. Let's do question 6.2. Determine the general solution of tan x is equal to 2 sine 2x, where cos x is less than 0, meaning that where cos x is negative. Right, the easy way to remember about the general solution is for you to remember what? To remember the cast diagram. Right, we know that in quadrant 1, we have our acute angle. Okay, we're going to be using x here, so let me use x, our acute angle x. And then in quadrant 2, we have 180 degrees minus x. And then in quadrant 3, we have 180 degrees plus x. And then in quadrant 4, we have 360 degrees minus x, okay, where x is the acute angle. And then this is our cast diagram. Only cos here in quadrant 4 is positive. All of them, all the trigonometric ratios here are positive, and then only sine of an angle here is positive, and then only tan here is positive in the third quadrant. So this will assist us a lot to deal with what? With the general solution. So for all the trigonometric ratios, we know that for quadrant 1 is going to be the reference angle. The reference angle plus what? Plus k times 360 degrees, where k is an integer. Then quadrant 2 is going to be 180 degrees minus reference angle, just like we have 180 degrees minus x here, plus k times 360, where k is an integer. Then quadrant 3, you see that we have 180 degrees plus reference angle. You see that? It's just the same here, 180 degrees plus x, then plus k times 360 degrees, where k is an integer. And then the quadrant 4, we have 360 degrees minus reference angle, and then it's just the same here, like 360 degrees minus x, and then plus k times 360 degrees, and then where k is an integer. Okay, because I want you to take note of this before we even do our solution. Let's say we have that, what example can I give? Let's say we get to a solution where we're saying sine x is equal to positive or negative 0.5 or 1 over 2. To get your reference angle, you ignore what? We ignore the negative sign. We just use positive 0.5. Even if the answer is sine x is equal to negative 0.5, just ignore the negative sign. Ignore the negative sign and get your reference angle just using what? The positive 0.5 as an example. Then this will give you an acute angle, which will be in this case like our x here. You see that if you use the negative, you may get what? An obtuse angle. That will not work. Okay, so when getting the reference angle, just ignore the negative sign and get your reference angle using the positive value. Remember that the identity sine 2x, the double angle, is equal to 2 sine x cos x. Remember that, okay? Let's try to get our general solution here. So tan x, we know tan x, an identity, we have to remember that tan x is sine x over cos x. So we have sine x over cos x is equal to 2 times, and then we're going to, the sine 2x is 2 sine x times cos x. And then we have sine x over cos x is equal to 4 sine x times cos x. And then what do? We multiply both sides by the LCD here, which is cos x. To get rid of the denominator, just multiply by it. And then we're going to multiply the left-hand side by cos x. We multiply the right-hand side by cos x. Then we get sine x is equal to 4 sine x times cos squared x. Then let's get our standard form. 0 is equal to 4 sine x times 0 is equal to 4 sine x times cos squared x. Then we transpose this. becomes negative sine x. Then what do? Do we have a common factor? The highest common factor, yes, we have. We have sine x, so we can factor out sine x here, becomes sine x outside, and then we have 4 cos squared x minus 1. We have factored out sine x. Then meaning that, therefore, sine x is equal to 0, or 4 cos squared x is equal to 1, because this is 4 cos squared x is equal to 4 cos squared x minus 1 is equal to 0. So we transpose the negative 1 to the right hand side, becomes positive 1 like this. Then we can say cos squared x is equal to 1 over 4, and then we square root both sides. So it becomes cos x is equal to positive or negative 1 over 2, because the square root of 1 over 4 there is 1 over 2. And then we said cos x should be less than 0. So we're going to take cos x is equal to negative 1 over 2. All right, let's go back to our, we want to write our general solution now. Let's go back to our castogram. We're told that cos x should be less than 0. Where is cos x negative? Cos x is negative in quadrant 2 and in quadrant 3. So that's where our general solutions are going to come from. Okay, let's start with sine x. Sine x, our reference angle here, obviously is going to be 0. So if we say 180 plus 0, or 180 minus 0, if you say 180 minus 0 is 180, 180 plus 0 is 180. You see that? Okay. So from sine x equal to 0, we are getting x is equal to, let me just divide this so that you can be clear where. Right, okay. X is equal to 180 degrees plus k times 360 degrees, where k is an integer. Okay, right. We're done with this part. Then when we come here, so we need to get our reference angle. What did we say? We say we're going to ignore the negative sign. So arc cos half. So x, or reference angle, let's say reference angle is going to be arc cos 1 over 2, which is equal to 60 degrees. So our reference angle is 60 degrees. Okay, remember what we said. We want quadrant 2 and quadrant 3. So it's going to be 180 degrees minus 60. Okay, you can go back to that information I gave you about quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It's 180 minus 60, okay, plus k times 360. So it's going to be x is equal to 180 minus 60, which is what? 120 degrees plus k 360 degrees, where k is an integer. And then the other one, quadrant 3, is 180 plus our reference angle. Our reference angle is 60 degrees. This is going to be 240 degrees. So it's going to be this, or this, or, okay, and then these two. Let me write it first. X is equal to 180 plus 60 degrees, which is 240 degrees, plus k times 360 degrees, where k is an integer. You see that? So these two are coming from this. You see that? Then done. Okay, right. And then if you check here, we could have done something. Where is it? Here, this point here. Okay, so in the next part, I'm going to show you from here, from this. Okay, this part will be doing the same thing up to here. Then I will show you an alternative way of dealing with this. Okay, let's just do that. So we said that we were having, remember this thing first. We talked about this, very, very important, and your cast diagram. Okay, remember that. And then we're saying that we have, let me just start from that point I talked about. We have 4 sine x, then cos squared x minus sine x. We had something like this, and then we factored out sine x. Do you remember that? Okay, but remember this cos squared x also is what? 1 minus sine squared x. Remember from our identity that we do in grade 11 is equal to 1. Then transpose, there we get cos squared x is equal to 1 minus sine squared x. Okay, right, so we replace cos squared x with 1 minus sine squared x. So it's 0 is equal to 4 cosine x, then times 1 minus sine squared x minus sine x. And then we can remove the brackets here. 0 is equal to 4 sine x minus 4 sine cubed x minus sine x. Okay, and then we have like terms here. We can simplify them. So 0 is equal to 3 sine x minus 4 sine cubed x. Do we have a common factor here? There is common factor. Yes, we have sine x, so we can factor it out. 0 is equal to sine x, and then 3 minus 4 sine squared x. Right, so meaning that therefore sine x is equal to 0, or 3 minus 4 sine squared x is equal to 0. Then 4 sine squared x is equal to 3. Then sine squared x is equal to 3 over 4. And then sine x is equal to positive or negative root 3 over 2. See that? Okay. All right. Remember, when you're getting our reference angle, what we do, we ignore the negative part. Let's get our reference angle. So our reference angle is equal to, you find arc sine of root 3 over 2, which is just 60 degrees, like the one we got. You remember that? Okay. And then we remember we said because of this, we are looking at what? At quadrant 2 and quadrant 3. And then here is 180 minus x. Here is 180 degrees plus x. Okay. So here our reference angle is 0. So we are getting, from this one, we're getting that x is equal to 180 degrees plus k times 360, where k is an integer. Or we come to this part, our reference angle here is 60 degrees. So we have second quadrant, 180 minus 60 degrees, which is 120. So x is equal to 120 degrees plus k 360 degrees, where k is an integer. Then we come to quadrant 3, 180 plus our reference angle. Our reference angle is what? 60 degrees. So x equal to 240 degrees plus k times 360 degrees, where k is an integer. Thank you very much. We are going to meet when you're doing question 7. Goodbye.